Hi guys, BuildZoid here, and today we're going to be taking a look at a Z490 overclock that I've set up with the Z490 Unify from MSI and also the 10900K from MSI, so thank you MSI for loaning me the CPU as well as sending over the board. Yeah, the memory setup is the, 4 sticks of the Patriot Viper Steel 4400 CL19. Thank you patrons for funding that. Anyway, yeah, so that's running here. The CPU is overclocked to 5.1 gigahertz. The cache is at 4.5 gigahertz. I'd consider this is very, very, I like the stability of this. The CPU is cooled with the 280 millimeter EVGA CLC, so that's some Asetek thing. Anyway, well, I've not run I've not hit this with a full CPU sort of stress test. Though I did run Linpack on this, and Linpack is very heavy. It's just that I didn't run it in sort of sustained load. It was like peak load from Linpack that I ran here is actually worse than Prime 95. The thing is, it sustains that peak load for a much shorter period of time, so the average power consumption is actually not that high, and the end result of that is that the actual CPU, the cooling system was just about able to keep up, as the CPU maxed out at just 100 degrees. I did have to raise the temperature target, so the CPU currently has a thermal throttle of 105 degrees instead of 100. The reasoning for that is if your CPU is thermal throttling, it causes some very nasty, the thermal throttling on the CPU causes some major problems for the power delivery, because the CPU essentially locks up every time the clock speed has to go up and down, which causes a very nasty transient and crashes everything. So you can't really, if you're stress testing and you're hitting the thermal limit and it's crashing, it might not even be that, you're running too little voltage. It might just be, your thermal throttling that causes crashing. Anyway, so, yeah, and the reason why I ran Linpack, so we'll just take a look at the Linpack settings. So I ran, 14 gigs of memory for the Linpack test, so... And the idea behind running that, and it's just 12 passes of Linpack, so it's just under 1,000 seconds total runtime, which is not, if I was actually serious about this, I'd run Linpack for an hour if I was doing this for my daily system. But the reason why I'm running Linpack here is because Linpack puts, it uses a lot of RAM, right? That's a 14 gig memory run, so there's a lot of data getting stored in the memory. There's a lot of data being moved from the memory to the CPU, and at the same time, the CPU gets very hot. So this is one sort of thing I don't like with Prime 95, is that it is very good at hitting, you can set up Prime 95 to hit your memory, or you can set it up to hit your CPU. You can't really have it do both at the same time. So if it's running, if you have Prime 95 running a lot of memory usage, it's not going to run that hot. If you have it running really hot, it's probably running entirely inside the cache of your CPU and not really hitting the memory at all. So it's really kind of, it's terrible for trying to find, say, memory controller instability. It's kind of bad at that. So that's why I used Linpack, because Linpack will just, hit everything, essentially, at the same time. So... yeah, 1,000 seconds of Linpack. It's not as I said, I'd run an hour. Some people like to do overnight stress tests. I think for something like that, it's kind of overkill. But hey, knock yourself out. I'm not going to tell you to not do that. It's just I personally don't see the need to do that. Maybe you're building a supercomputer, then sure, go for it. Anyway, so yeah, Linpack passed, and the main reason I use this, the thing it helped me detect while setting up this overclock is I initially started with 5.1 gigahertz CPU, 4300 megahertz memory, and 4800 megahertz cache. So uncore is the other thing you can say, or ring ratio, ring, cache, uncore, same thing. If you hear somebody talking about uncore clock on Intel or cache clock or ring clock, they mean the same thing. Just different terminologies by different motherboard vendors. I'm actually not sure that anybody calls it cache anymore. But yeah, ring and uncore is the common term. Anyway, so the thing is just I started with relatively high uncore clock. That turned out to not be very stable at all. The problem with uncore clock is that uncore, the uncore is powered by the vCore. So essentially, if you want to stabilize a high uncore, you're gonna need one of the things it does is it drives up your V core. So if you're so basically, you can end up in a situation where your CPU is gonna running a high uncore can require a lot of voltage, and that can translate into very high temperatures that aren't actually helping your CPU core clock very much, but they're necessary just to sustain that kind of, uncore clock. So, yeah, I ended up at 4.5. I think I might have been able to work it back up at this point. Like maybe 4600 would have been stable, but I'm just happy that it finally passed LinPack because, yeah, I was having issues with it, like initially with as I was dialing this in, initially it was like I couldn't do one pass because initially I had my voltages set way too high. So right now the voltage on the CPU is set 1.4 volts, but with mode 6 load line. So there's a lot of droop on this, and I ultimately don't know the load voltage. I'm guessing it runs around 1.2 volts at full load, just because and even then it was hitting 100 degrees. So like mode 6 is like the two, like the board only, like the worst droopiest LLC on MSI motherboards is mode 8. So I'm literally one setting away from having as much droop as the motherboard supports essentially. Um, but yeah, so the CPU is at 5.1. It's quite stable. We can't run I would also I wouldn't just run LinPack. I'd also run some Prime 95 on this if I was going for full stability. But the LinPack is okay because the average power consumption is not that bad, even if the peak is really high. I can't run Prime 95 on this for an extended period of time because it'll just overwhelm the cooling system completely. And yeah, I don't really want to do I'm not gonna go and build I don't feel like swapping out my X2. Well, I've not done anything on that system for ages, but yeah, I don't really feel like swapping in a different cooling system just to be able to run Prime 95 on this right now. Yeah, I like LinPack just to get a good indication of is the memory controller stable, is the cache stable, is that kind of thing stable, because Prime 95 is not that great at detecting those kinds of issues. Anyway, and then I just ran 600% of mem test, which is just to check the rest of the memory. Now, technically, LinPack does have a 30 gig data set option. The problem is that one would sustain the peak power consumption for long enough to actually overwhelm the cooling system, so we're not running that either. It's the same logic as for why I didn't run Prime 95. Anyway, you can see that mem test here. So this is, you can see this is using basically 98% of the memory right now on the system. So actually, there's other stuff open, so it's probably more like 91%. But most of that is, or not 91, but probably 96% of the memory being used is mem test. And as you can clearly see, we've passed 600%. The sort of recommended minimum number of percentage for mem test is 400%. Yeah, here it's at 600%. So you could consider this very I'd be fine dailying this. I wouldn't see I would daily this if I had some weird crashes with it, then I'd start wondering if my stress testing was suboptimal. But this is honestly this system right now in its current configuration is probably more stable than the system currently being used to record this video. So yeah, that's I'm not very happy with my daily system. Let's put it that way. It's literally below, it doesn't pass even my own stability testing standards. I'm not very pleased with it. So when it randomly crashes on me, it's no longer a surprise. It's just kind of well, that's a fact of life with how I've decided to configure it. So yeah, and the memory, so let's talk about the memory at last, right? So the memory here is running 4266 CL16, 1818 for TRCD and TRP. TRCD and TRP on Intel mainstream systems is linked, so you can't run a different TRCD from your TRP. So if you set TRCD 19 and you set your TRP to 11, you're going to be running 19 TRP because Intel's memory controller just kind of does that. Similar to how on AMD systems you can't adjust TREFI because AMD doesn't expose that timing. Or I'm not sure it's even adjustable. It might physically be, they might have a baked-in TREFI where it's just because I think it's the standard is you have to refresh every like there's standards for like how many microseconds between refreshes there's supposed to be. So I'm assuming that AMD just has a like it's not even like a timing. It's just like the memory gets refreshed on this time interval no matter what. Anyway, yeah, so this right here, so that's the primary settings. I did tighten up the secondaries and the tertiary timing, so the bandwidth on this is kind of ridiculous. And some people might be wondering, wait, this is the 4400 megahertz Patriots. Why aren't you running them at 4400? Right, so 4400 CL19 right there. We do have 4 of them. Like, why aren't I running 4400? The thing is, the board can actually boot 4400, and it's probably even stable, but it only works at really loose timings. And, well, having a high memory frequency, you can think of, like, frequency is your, sort of sets your potential for maximum memory bandwidth, but your timings are actually what decides if you're going to have any performance, right? Like, if you have very high frequency, but your timings are set up so that you're wasting most of those clock cycles doing absolutely bloody nothing, then you haven't really, like, you can set up memory overclocks where like a 5 gigahertz overclock is slower than a 4000 megahertz overclock. Like it's not a problem to do that kind of thing with just setting up the timings loose enough on the high frequency stuff. So I went for 4266 because this is where I can actually hit really, really nice timings. Also, I might have forgotten to mention there's a fan sitting on top of the memory, which is kind of cheating in the opinion of a lot of dirty casuals. It's like if you putting a fan on your memory is cheating. Like, nobody runs fans on their memory, and my response to that is, have you heard of zip ties? Well, if you have, get creative with them, and I'm sure you can have a fan on your memory too. And then you won't have to worry about, like, the B-die's temperature sensitivity will be less of an issue. I'm not actually sure that the fan is necessary. It's just, like, I just kind of threw it on there. And honestly, like, there is a fan loosely sitting in the computer that's recording this video. So if I was dailying this, yeah, I'd have the fan on the memory anyway. Like, and some people might be like, but it looks ugly. Well, I guess you don't like having high performance then. I mean, there. That's my response to that. So, yeah. So that's kind of the setup here. Let's just quickly, we're going to run some benchmarks on this. Because, yeah, this is very stable. Like, it runs freaking LinPack, and LinPack is heavy. Mem test was passing, right? So the memory is stable, the memory controller is stable, the CPU, I'd say, is 99% stable. I'm not going to say 100, like, you can't say 100%, but because, the thing is, I've not actually run an hour of LinPack, and I've not run even, like, any Prime 95, actually. But, yeah, it's a nice stable setup. So I'm actually wondering how, like, relatively stable setup. It's not far off from potentially being fully stable. I think the only thing, hey, I'm not concerned about the memory settings here. I'm mostly concerned about, is the CPU actually stable? Is the cooling system actually good enough? That's kind of my current doubts with the setup here. But yeah, like a lot of people, they don't even run LinPack or Prime 95. They run something like RealBench or like, if you stress test with Cinebench, then I got news for you. Cinebench is not a stress test at all. Like, don't stress test with Cinebench. That doesn't count. Like, if you like, you can finish Cinebench at settings that are so incredibly unstable that, yeah, it's a nice, fun little easy benchmark, but it's not a good stress test at all. Anyway, so that first score was 6650, well, 6655, which is a bit disappointing. Unfortunately, Cinebench doesn't scale that much with memory, so even though, like, the memory setup here is pushing, it should be pushing around 64, 65 gigabytes per second. Yeah, it's not really doing much for Cinebench. I guess we should run some Geekbench as well. Yeah, that's a good idea. Let's run Geekbench. Somebody's going to be like, Buildzord, you're just padding the video length. I'm not. Like, I actually want to, well, maybe. I guess I could edit it out. Or I could have been running the benchmarks while talking about all the cooling stuff instead. But that would require way too much planning on my part with the video. And there we go. It's a great Cinebench score. Also, Cinebench, you want to rerun it a bunch of times normally, because it does actually, the score tends to improve as you run it more times. Anyway. Also, it's just an inconsistent benchmark. So let's just run Geekbench. You know what would be really funny? If Dijkstra crashes while everything else didn't. I'd be super disappointed if that happened. But Dijkstra is like... It hits memory controllers pretty hard. Let's put it that way. So yeah, you generally, like, if you're stress testing, you know, I'd say, like, the more different sort of heavy workloads you throw at your system, the more certain you can be that it's actually accurate. Well, that it's actually stable. But yeah, Dijkstra passed. Of course it passed. Like, this thing, this is more stability tested than my freaking daily system. Of course it's finishing Geekbench. I feel really bad about my daily system. I should upgrade. Anyway, so yeah, and we're actually getting like that's a nice memory score in Geekbench, 9.1K. If you remember, I showed like the highest Geekbench I managed with this setup, like even pushing ridiculous volts and just no care in the world for anything like, you know, the memory controller actually surviving. It's not my CPU, it's on loan. So no, the thing is the motherboard actually defaults to ridiculous system agent voltages. If you try to push like 4800 megahertz, the board will default to 1.65 volts as system agent. So basically don't leave the system agent voltage on auto because while trying to push frequency, because the board is very voltage happy. Anyway, yeah, it goes 9100. So yeah, and when I was doing the sort of ridiculous 4266 CL13 overclock with the tightest timings possible, at least within my capabilities, I'm not the world's best memory overclocker. You know, I was doing 9800. So this is actually not far off of the sort of best memory performance that I managed to do for Geekbench on this. Let's run some IDA, and for once, I will actually run it correctly, because I had no idea that the cache and memory benchmarks, that you can just double-click the memory thing. Like, it doesn't look like a button. Why would you think to double-click the memory to run just the memory tests? So, yeah. But I've learned now. And we're doing just under 64. I swear, every time I run IDA on this setup, it slows down. Because I had read tests that were doing like 64.5. Then I did another one and it was like 63.9, and now it's 63.7. Though the write test is fine. That's at 66 gigs. So, yeah. And latency is going to be 44 nanoseconds. The latency is unfortunately really high. And there's not really anything I can do about that. I think it's just, yeah, it's 43. So, yeah, I'm kind of disappointed with that. I think we'll find, like, I expect to find with testing motherboards that do better latencies, but yeah, I like, because this is like, compared to some of the stuff I've done on Z390, like on Z390 I was pushing sub 40 nanoseconds on a lot of configurations, and here it's doing 43.3. So this is quite a disappointment to me. Anyway, but yeah, like, that's a lot of bandwidth, even if the latency isn't that great. We've run Geekbench, we've run Cinebench. There's not really any other benchmarks I want to run, so I guess let's go into the BIOS and take a look at the settings. Ah, there we go. So yeah, 5.1 gigahertz CPU, 4.5 ring ratio. You know, now that I'm kind of certain that the memory is actually fully stable, I would, because basically I was tuning everything at the same time, so there's a chance that, like, the last thing I gave up on was the 4.3 like, for a long time I was trying to do 4300 memory, so it took me a while to accept that that wasn't going to happen, not at the timings that I wanted to run anyway. So yeah, there's actually, like, I could probably raise the ring ratio back up now, but we're not going to do that, just because then I'd have to run LinPack again, and then, you know, like, retest everything fully, and it's just like, yeah, I'm not interested in doing that. So 4266 memory. Also, let's just go to the advanced CPU configuration. So Yeah, is there anything really? Right, so I bumped up the temperature limit to 105 because I really didn't want it to thermal throttle while running LinPack, because that just completely throws off any stability that you might have. And for day-to-day usage, I would not necessarily have the OTP set to 105 degrees. And if your use case is regularly going up to like hitting the thermal throttle, then you probably should just back off the overclock or get a better cooling system. Um, like, yeah, I wouldn't really, you know, like this is nice for validating stability. It's not something I would actually use for long-term use. Like I wouldn't run a CPU at 110 degrees in like rendering applications. Like that just seems like a great way to kill the chip. Um, yeah, for stress testing, if you don't actually like, if you don't really have any plans, like you want to know that the system won't just insta crash. When doing heavy things. Though actually, if you test with 105 for stress tests and then you thermal throttle in regular day-to-day use, then well, that's the point. Thermal throttling is supposed to get you to shut down the system, isn't it? So I guess if it crash, oh yeah, that's actually kind of okay. It'll alert you to the fact that there's a problem at the very least. So we have PCIe spread spectrum is disabled. This stuff is disabled. I don't think it was necessary. What else is disabled? Not much, really. Yeah. Anyway, so then for the memory, it's just, let's just go through the timing. So 2T command rate, because your dual rank basically doesn't do 1T in my experience at all on mainstream Intel CPUs. It's just not really a thing. TCL16, TRCD18. TRCD is memory controller limited, not CPU limit. I mean, not memory limited. So the memory could actually probably run 16, 16, 16. But if I try to do that, we're going to get a 55 postcode, which basically says memory controller not good enough. Like 55 essentially, like in my experience with this motherboard so far, if I get the 55 postcode, the best solution is to raise the VCCSA or raise the TRCD timing. One of the two, which both of them are basically like TRCD hits the memory controller really hard, as in lowering the TRCD puts more strain on the memory controller. And then raising VCCSA, well, that takes, like, that just, improves the stability of the memory controller. But we're already at relatively high VCCSA here, as you'll soon see. So 16, 18, 18, 36, 300 TRFC, that could probably go lower, but I'm not really like 300 is about as fast as 280 anyway, so I don't really see a point in pushing that lower. 40,000 TREFI, just because I know that that's actually stable, like that's not going to cause data, like, because the refresh timings are used to actually maintain, like, keep data in the memory, because DDR memory needs to refresh, because the way it's structured, it uses a bunch of capacitors for storing the data. The capacitors leak voltage, so if you don't refresh the memory ever, you're eventually going to lose all the data that you tried to store in it, as in all of the ones that you write to memory just will turn into zeros, and, well, then you're screwed. So the problem with the refresh timings is that they're kind of annoying to, like, if you're constantly using the memory, you might not run into the same issues with the refresh with the refresh settings as if you're just sort of idling and not doing anything. I've heard of people having like issues with the system recovering from sleep if they have too much, if the TREFI is too high and the TRFC too low. But 340,000, I know for basically a fact that they're stable. So, like, I'm actually running, like, I think there's a profile on one motherboard that's like 44,000 TREFI, and I'm running below that, so we're fine. Also, your TREFI actually, what's kind of funny about it, as the frequency of your memory increases, your stable TREFI, like, theoretically, if at 3000 megahertz, your maximum TREFI is 30,000, then at 4000 megahertz, it should be 40,000, because at 4000 megahertz, each of those clock cycles is 33, like, you have 33% more clock cycles. So if you still had a 30,000 clock cycle TREFI, you'd actually be refreshing 33% times more off. Wait, am I getting that right? I might be wrong on the math, but you'd basically be refreshing more times per second. Whereas you just need to, there's basically just a requirement of, like, for the memory chip, you need to refresh this many times per second or you start losing data. That's essentially what the stability requirement for that timing is. And so 40,000 at 4266, perfectly stable. There's no concerns with that. TWR 16, that could probably go lower, but it also, like, that timing doesn't really do much for performance, so I just kind of leave it, like, at 16 it's stable, I'm not going to fight it. TWTR 4, TWTRL 8, this is just kind of my default BDI timings. Like, technically they can probably go lower, the performance doesn't change too much though, so yeah, 4.8 is good enough for me. 4.4 for the TRRDs, they literally don't go lower, as in you cannot set them lower. And that's just a limitation of how the memory controller and the memory works. RTP12, that's actually the same as the auto setting. That timing, in my experience, causes more stability issues than it gains performance, so I don't mess with it. TFall 16, you can try set it lower, but it doesn't do anything because TFall essentially is an extension timing on top of whatever the whatever 4 TRRDs are. So if I set the TFall to like 8 or something, it'll be stable, but that's not because it's actually improving performance. That's because we can't have a TFall lower than 16. Like because the TRRD timing is 4, you can't have that. Like TFall is for basically adding extra delay after your TRRDs take place. So if your TRRDs are 4 and your TFall is less than 16, it's not going to add any, like, it's not going to do anything because there's no delay to add. The TFall is shorter than the TRRDs. And if your TRRDs are, say, like 4 and you set a TFall of 20, then after your TRRDs happen, it's going to add 4 clock cycles to it. So that's essentially what that timing is for. So we could set it to 9, but that doesn't do anything. So 16 is as low as it goes. And I've also explained that really badly, but because I don't actually remember the official documentation for it. Like, I read it at some point. I basically just remembered it can't be less than 4 times TRRD. That's basically my understanding of TFall. Like the part that I remember, like, this can't be less than 4 times your TRRD. Or more like, if you set it less than 4 times your TRRD, it doesn't actually do anything. TCWL 18. This is a massive disappointment. This is probably part of why the latency on this board is so bad. And it also doesn't go any lower. So TCWL, normally you'd expect it to do 1 or 2 ticks below TCL. But maybe something changed with the memory controller going from Coffee Lake to Comet Lake. I kind of doubt that. I think it's just a board limitation because I've run into this before, even on like Coffee Lake boards. Like, I had one board where for whatever reason, if you wanted to run high frequency, TCWL had it to be like 20 or something. And it, like, you could run TCL 14, but if you set TCWL below 20, it wouldn't post, which was completely stupid. But yeah, so here, this is stuck at 18, which doesn't really make sense because generally TCWL should be either equal to TCL or 1 or 2 ticks lower. But at 16 or 16, 15, 14, the system literally won't post. So yeah, they can't lower that. TCKE 2, that's as low as it goes. You can't set it any lower. It just goes straight to auto. So yeah, TCCD 4. I've not tried to lower that, but that's because in my past experience, trying to lower that timing generally causes things to not post. TCCDL 6, this is actually an improvement over stock. Stock would normally have it, like, if I left that on auto, it would be at 8. 6 is stable, and it works. So yeah, I've not actually tried lower than 6 because generally that one bottoms out at 6 in my experience. So anyway, then tertiary timings, these are all 1 tick lower than stock, so normally that would have defaulted to 8. These are fine, so 4, 6, 6, that's fine. If I wanted to, I could lock those in. Then 4, 7, 7. I actually tried lowering these. That doesn't work. I tried running these lower. So these default to like 15 or 16, which if you lower them from that 15 or 16 down to 11, significant improvement in terms of memory bandwidth. So these 4 timings right here are big for your memory bandwidth. They can potentially go lower with more voltage. So right now the memory is at 1.5 volts, and so these don't go any lower. Well, I can boot at 10, but it's really unstable, or more like it's not stable. So I think I tried 8, and that was the one that was really, really unstable, and 10 was like kind of not stable. So anyway, 11 works. Obviously 10 would get more bandwidth, but it might need more voltage or a lower frequency, and then it's just like, okay, that's not worth it at that point. And then these two are set to 8, 8. I tried 7, 7. I was having stability issues. so those ended up at 8. Auto would have them at 9, if I remember correctly. Or one of them was at 9. So, yeah, and then everything else is just auto. The motherboard is good at dealing with all the other things, because I'm not. So, yeah, all of this stuff down here is like, that's where the BIOS vendors can sort of, I mean, motherboard vendors can make adjustments to the BIOS to give you better memory support without actually changing the physical hardware at all. Is just adjusting how the auto behavior of all of those extra subtimings behaves, as well as as well as this lovely menu, like all of this stuff. So, yeah. Anyway, so here's the CPU settings, 1.405 V-Core, which might sound really high, but if we go into the digital all power, you'll see that I'm on mode 6 LLC, which is very droopy, and I have no idea where the load voltage actually ends up. Maxed out voltage protection because, well, I don't want it shutting down. Enhanced overcurrent protection, I really don't want it shutting down because of like current draw. Like, I'm running LinPack on this, so like, I don't know if without the enhanced overcurrent protection it might not shut down, but the VRM on this is super overkill, so yeah, I just have that on enhanced. Like, there's no reason that this VRM should have a problem with the current draw. But if they told you like how much current this was actually set to, that would be great. But apparently, I guess that would be scary for a lot of new like beginners to have a current setting that's like OCP set to 250 amps, and then the next setting was like 300 amps, 400 amps, 500 amps. Because to a lot of people, you say 200 amps, and they start thinking like, oh my god, it's going to start a fire, and it's like, no, it's at 1 volt. Like, what did you think your CPU pulls? If your CPU runs on 200 watts of power and it runs at 1 volt, how much current does it need? Right? Simple math. Anyway, CPU switching frequency 600 kilohertz. I had this up at 800 kilohertz at one point. It wasn't really doing anything for stability. I also had it at 500 kilohertz. It wasn't really doing... Like, I'm not sure that is actually doing anything, because I didn't have the, like, I need to, once I have the probinator, I'll actually check if that does anything. I've had a lot of boards where changing the switching frequency, like, there are some boards where if you raise the switching frequency, things get worse. And then there are some boards where changing the switching frequency just doesn't do anything at all. I think this board is in the camp of that setting actually doesn't do anything. Yeah, like, that's set to 600 kilohertz. I know for a fact that setting the CPU SA switching frequency to 1000 kilohertz causes the VRM to shut down. So don't do that. Like, I've tried running it with 1000 kilohertz. It just shuts down. So yeah, I'm not sure why MSI has that available in the BIOS. I'm guessing they don't actually run that. Like, I'm guessing they don't run that setting in their own internal testing. It just kind of exists, so they're not aware. Like, it shuts down. Like, I've tried when I was setting up my crazy Geekbench profile. I tried to have system agent switching frequency at 1000 kilohertz, and the board, like, it looked like OCP essentially, and I was like, well, that's really weird. But yeah, it seems to just be like the VRM just trips up on some kind of issue with 600 kilohertz. VRM temperature protection set to auto. I don't know what the temperature limit is, but this VRM doesn't get hot in the first place. Like, this is a 16 phase using 90 amp smart power stages. I am not very worried about the temperature of the VRM. So yeah, that's the sort of the core voltage settings. Override mode for V-Core. Because I don't really want to deal with, I like static voltages are easier to stabilize as far as I'm concerned. And I've had people tell me that adaptive voltage is more stable for them. And then and I've tried replicating their data, and I've just kind of come to the conclusion that they're just bad at measuring things. So, yeah. There. Anyway, CPU system agent voltage is at 1.38 volts. Now, some people might be like, Buildzoid, don't you normally recommend people stay below 1.35 volts? And it's like, yes, you're correct about that. However, I've gone to some, the thing is, with a lot of my voltage recommendations, I tend to err on the side of caution. And 1.405 volts idle voltage is perfectly fine. Like, the CPU is not going to die from that. So yeah, that is on, like, I would go all the way up to 1.42 or even like 1.44 volts, especially with as much V-droop as I'm running. So, like, Intel 14 nanometer is very robust. So, yeah, very, very difficult to kill these chips. Like, I've run benchmarks at over 1.5 volts on water cooling on 14 nanometer CPUs, and they're still fine. Admittedly, like there were light benchmarks, not like Prime 95 or anything. It was like 3D Mark, the Firestrike CPU test that doesn't really pull too much power, that kind of thing. But yeah, so this is fine. Like that voltage is perfectly fine. I'm not concerned about that. The system agent voltage. So anyway, I consulted some other sources about system agent voltage, and I came to the conclusion that my 1.35 volts, like, it's definitely not wrong, but it's definitely like more on the cautious side. Um, so yeah, 1.38 is also fine. Actually, even up to like 1.4 volts, you should be fine. There's just like, well, I actually had this at 1.4 volts when I first started, and I think it was actually causing instability. Like the extra system agent voltage was actually causing more harm than good. So I do think there's like a level at which the you can have too much system agent voltage where it's not even like it's harming the CPU, it's just like a problem for stability. Um, so yeah, 1.38 volts, it's safe. Like it's still relatively safe. It's definitely, going towards the high end. The thing is, I've never actually killed a CPU memory controller yet. Not on an Intel 14 nanometer CPU yet. Like I've killed other CPUs, though not with. No, there was one CPU where I blew it up with Northbridge voltage. So okay, um, but yeah, I've not killed any 14 nanometer chips with system agent yet. And yeah, so 1.35 volts if you want to be extra safe. 1.4 volts if you're feeling a little bit braver. Though even like 1.4 volts should actually be completely fine, and so 1.38 volts I don't really have a problem with. IO voltage, 1.28 volts. That's still below my old recommendation, because my old recommendation was always 1.35 volts for both. So, yeah, that's fine. IO voltage is 1.28. And IO voltage can help with stabilizing high cache frequencies. That's just kind of worth noting. Anyway, and then all the other voltages except for memory voltage are auto. You might be like, Buildzoid, isn't that BIOS voltage reading saying 1.516 volts? And you'd be very correct about that. I don't trust BIOS voltage readings. And I've checked MSI boards in the past for memory voltage, and if you punch in 1.5 volts, the DIMMs actually get 1.5 volts, but for whatever reason, the BIOS reports like 15 millivolts high, and that's been the case on basically every MSI. Actually, most motherboards do that, where it's like if you check the memory voltage with an actual multimeter, it's like spot on. And then if you check the software readings, it's off by 10, 20 millivolts pretty much always. So I set it to 1.5 volts. I don't care about that 1.516 volt reading because it's probably wrong. I've just not been bothered to prove that it's wrong, but it's also like it's still probably wrong. Also, BDI is very, very tough, so I'm not very concerned about it being like even if it was actually at 1.52 volts, I don't like it's not really a problem. So yeah, that's the setup here. So if you're gonna be running like 4x8 Samsung BDI, then you're probably gonna with this motherboard and a 10900K, then you're probably gonna want to aim for something like this in terms of timings. And also these two, the TWR RD and TWR RD SG, those are on auto because there's a pretty like complicated relationship between the cast latency and the WTRs and some other timing, and I don't care for that relationship at all, so I let the motherboard deal with it for me. And the motherboard knows how to set them, right? Like the motherboard sets those correctly. So if I wanted to run like less WRDSG, then what I would do is I would go up here and wait. Which one's the... Yeah, so SG is the long one. So I would lower... I think this one is the one you lower. And this is totally not going to post at this point, isn't it? Nah, it posts. Yep, it posts. So... Yeah, so if we go down there, you'll see that one of them is now one tick lower. So now it's 4.7, and previously it was 32.28, and now it's 31.28. Yeah, so I was right. So, yeah, that's why I leave them on auto, because either you're going to be setting your WTRs or you're going to be set, like, one of the two has to be on, like, yeah, one of the two you're going to leave them on auto, because otherwise they're, like, you could potentially set them to things that aren't compatible. As in, like, you could punch in, like, I could have 4-7 here, and then I could punch it 32 down there, and that doesn't work. Not as in it won't post, it'll just ignore one of the two settings, and it's just like, so don't do that. Just let the board deal with the difficult ones, which is these down here, and set the WTRs yourself. That's my workaround for that. I'm not going to deal with it. Yeah, so that's this overclock right here. And this is like, Linpack Extreme is like AVX, like heavy AVX. So yeah, I'm pretty like happy with the settings right here. Like 5.1 gigahertz. I'm not really like, I wish I could push the cache a little bit further, but the thing is, the cache really is annoying to stabilize. And it just like, it scales with vCore. So it like, that's the biggest issue with it, is just like, if you want to run high cache and you're not like IO voltage limited, and you're actually vCore limited on your cache clock, as in you need more vCore to get the next cache ratio, well, if you bump up the vCore 20 millivolts, like, or 30 or like, if you bump up the core voltage, your power consumption goes way up really quickly, right? So that's kind of the thing, is like high ring rate, like the ring ratio itself, it does have an effect on performance. It's not that big, and so I'm willing to, sacrifice cache ratio for not having to run a stupid high V core. So yeah, that's kind of that. Did I change anything down here? No, I didn't. So yeah, that's the settings for this overclock, and yeah, you might want to aim for something like this with a 10900K, and I think I'll actually probably send off this memory profile to somebody to actually test, like in like gaming workloads and that kind of thing, because I don't test games. But yeah, this should be, I'd say this should be very achievable. I'd say this isn't even that like I don't think I'm pushing this system that far in terms of the memory settings. Like, it was booting 4400. It's just like, it wouldn't do tight timings at 4400, where it's like, maybe if I raise the system agent voltage high enough, it would have done it. But, then we'd be going well over 1.4 volts. Because we're already almost at 1.4 anyway. So yeah, that's it for the video. So I guess thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, which you can find a link to down in the description below. That's, what I use to do, well, that's how I got like the Patriot memory kit here. So yeah, that wasn't sent to me by Patriot. Like, I've actually gone and bought every single set of Patriot Viper Steel that I have. I actually have a lot of the sticks, a lot of these sticks, mostly because, well, yeah, I have 6 sticks in total. Admittedly, only 4 of them are B-die, but yeah, like, I like the B-die kits. The CJR kits, well, it's CJR. CJR is a disappointment. Like, CJR is not great. Anyway, yeah, so Patreon. Other than that, there's also the AHOC Teespring store, where you can pick up shirts, stickers, posters. You get the usual YouTuber merch, and that achieves the exact same thing as the Patreon, except you actually get merch in return instead of well, basically nothing for the Patreon, right? Like, you get to make, like, with the Patreon, you help make these videos possible. With the Teespring, you still help make these videos possible. You just also get stuff in return. So yeah, that's it for the video. Thanks for watching, and goodbye.